This lesson is a conceptual overview of properties of real numbers. Properties of real numbers can be used to simplify expressions. The first property is the commutative property. Think commuting, in the sense that the two terms switch orders, either multiplication or addition. Associative property is where the association changes. So you'll notice ABC is in the same order. No order changes occur because that would be commutative, but the association changes. So B and C are completed first here, whereas A and B are added first here. Then you have the inverse property. The inverse can be additive inverse or multiplicative inverse. You'll notice additive inverse is the opposite number. Multiplicative inverse is the reciprocal. The identity property, identity means what number is either added so that nothing changes or multiplied so that nothing changes. Anything times 1 will stay the same. Anything with an addition of 0 will also remain the same. Multiplication by 0 always results in 0. And then we've got this property, which is very helpful in simplifying expressions, the distributive property. The distributive property tells us that we can multiply over an addition, so A times B and A times C. The plus minus here is just written so that you can see that it could work with a plus or a minus, and the number could be in front or afterwards. We also have terms. Terms are products of numbers and variables. Here, A is a term and B is a term. We have two terms in this expression. Some more examples of terms could include 2x, that's a term, pi r squared, that's a term, even a whole set of things that are multiplied together like negative 2/3 x, x minus 1. That whole thing is a term because any plus or minuses are within brackets. As soon as you go plus something else, then that's two terms. Like terms end with the same variables that are raised to the same powers. However, the coefficient can be different. So the numerical coefficients can be different. And when combining like terms, you add the numerical coefficients. Now, what are numerical coefficients? Well, let's just quickly look at an example. Say you had 2m minus m plus xy squared. So here, the numerical coefficient is 2, -1, and +1. But this third term is not the same as these first two, so only the first two can be combined, which gives us 2m minus 1m, you can put that little 1 in there if you like, is m plus xy squared. Here's some more examples. Simplify the following expressions. You can try these and then see if what you did is according to what I'm going to do. There are several ways of doing it, but this will give you some guidelines. So remember, you're using the properties defined in the previous slide. Okay, let's look at the first one. The first one says to simplify, and they all say to simplify. But what we want to do here is, because we cannot do anything more to separate the terms, we need to see if there are any like terms. So the 2 does not have an ending, neither does the 1. So those two terms can be combined. 2 plus 1 is 3. There's also terms ending with an x, so positive 1/2 x and negative 1x. And nothing else ends with an x. So can we compute 1/2 minus 1? Yes, we can. That gives us negative 1/2 x. You can also write that as negative x over 2. Finally, we have the positive 5x squared, negative 3x squared, giving us a positive 2x squared. Now, usually we write, and this is fine, but we usually write expressions in decreasing exponential order. So we start with the highest degree, and we can write it like that, so that the exponents are in decreasing order if possible. The next example, we need to first use the distributive property to distribute a negative 1 multiplied by the terms here, giving us 3x minus 6y, and then negative 2 multiplied by the next 2, which gives us negative 2x plus 6y. Now we can see if there are any like terms. We've got 3x minus 2x is 1x. You can just write x if you like. And negative 6y plus 6y, which is gone. So it's just x. Here we've got 3x times 2y, which is 6xy. Notice there's no distribution here because there's no plus or minus. This is all just multiplied, and this bracket is really there just superficially. This next part, you need distribution, so you need to multiply negative 5x times y, which gives us negative 5xy, and negative 5x times negative 2, which is positive 10. Then we can cap it off with a negative 7. We've got some like terms, same endings here. 6xy minus 5xy, which is 1xy. We can just write that as xy, and then the 10 and the negative 7 can also be combined to give us positive 3.